Right, this is day 2 of transformations. We're going to first just review some key concepts that we learned in our last video from interactmath.com. So this will walk you step by step. If you need a little additional support or practice at home, you can always view an example or they'll help you solve through some of these problems, and it's a really good website. But anyways, the one that we have here is absolute value. That's the one that we're going to deal with the most. We're going to identify its vertex. So remember, we can do that from just looking at it. Anything on the inside is opposite thinking. So in this case, it would be a positive 4. And then anything on the outside is our y value. So that would be our vertex ordered pair. And fantastic. And then it will take you on and you can do some more examples. But our axis of symmetry, what it's asking for now really is just what's that line going to go through the x at? Well, it's going to be wherever that x is there. So really you're just your same one. But there's a couple other examples. Actually that was a really good one, that next question. But let's look for one where it's a transformation and it's asking for what's happening here if they give me one. And I don't think they quite have one. All right, let's go ahead and switch over to our notes. So let's talk about dilation, so shrinking or enlarging, and how that works with our functions here. So we've got our original form, where we might have some things being multiplied in the front or in the inside. So here's our original one. If we do have something in the front here, everything outside we remember is vertical. So outside, vertical. And depending upon if it's a big number or a small number, it's going to be a stretch or compression. Stretches are bigger than 1, compressions are fractions when it's out front. Horizontal stretches and compressions are going to kind of do things like this, horizontally moving it, and it's opposite thinking when we're still on the inside. So that does follow through with even dilations, that opposite thinking when it's on the inside. So let's go ahead and take a look at these first examples. We have absolute value, so I'm going to first just go ahead and draw my parent function. And then we're going to, I don't know where to draw my points now because I've got this vertical, because it's outside, this vertical, and since it's a fraction, it's a compression. So this vertical compression, which means it's going to kind of press it down. And it's a vertical compression by 1/2, if we want to get specific there. So what we could do is create kind of a quick little table, and that would help me plot my points. So if I wanted to try and plug in some values for x, let's just go ahead and try the classic -1, 0, and 1. So -1, the absolute value, if I plug that in for x, I'm going to get 1 times 1/2 is 1/2. 0, the absolute value, 0. 0 times anything is 0. And then 1, same thing, I'm going to get 1/2. And I could even keep going and do 2, and 2 times 1/2 after I do the absolute value is 1. And then I can go ahead and plot these points. So -1, 1/2, 0, 0, 1, 1/2, 2, 1. And then I can go ahead and draw my new, and there it is. And there it is. All right, so we can now see that it's been compressed or kind of pressed down vertically. Kind of smashed down vertically there. All right, the next one, we can see that since it's outside, let's do, let's change it into absolute value. And I'm going to go ahead and actually make it on the inside. So bear with me on that change. There we go. All right, so let's go ahead and graph our original absolute value of parent function. All right, and then we're going to go ahead and make another little table over here. And we'll pick some values. And pick a few more this time. Okay. So since it's on the inside, it's horizontal. The writing's kind of going together there. Horizontal, and it's opposite thinking. So even though it's a big number, we're really doing a compression. So it's normal thinking out front. So fractions are compressions. Whole numbers bigger than 1, so no fractions there are stretches. But inside, so this is going to be a compression by 2. So opposite thinking when it's on that inside. So plugging in these values, we would get -4, which would change to +4. 2 times -1 is -2. Absolute value would change it to +2. 0. And then 2 times 1, there's 2, and 4. All right, so graphing those, we'd have -2, 4, -1, 2, 0, 2, and 4. All right, so we can, there it is. We are now horizontally compressed, so it's kind of pressing it on its sides, pressing it up horizontally from left to right. So you can kind of see how it's pressing it up that way and pressing it up that way, which is compressing it horizontally. So making that table will help you, because it's kind of hard to visualize those compressions and stretches. So let's go ahead and just describe what's happening on these next few examples. So remember, anything on the outside is vertical. Okay, anything on the inside is horizontal. Horizontal, hug the inside. So here we are in the inside, so it's going to be horizontal. That's the first thing we need to say. And then we think opposite, so it being a fraction, it's not a compression, it's opposite of what we think, so it's really a stretch. Stretch we think bigger, compression we think kind of smaller in a sense, and it's by 1/3, because that's the factor that it's multiplied by. Next one, since we are outside, we are vertical. And since it's a fraction, it's normal thinking of compression by 1/2. So try those last two on your own. All right, and hopefully you got horizontal, opposite thinking, so it is a compression by 4. And then this last one is still horizontal since it's on the inside, but this time it's a stretch, opposite thinking of, even though it's a fraction, we think opposite, so think bigger, so think stretching by 1/4. All right, this last one, we're not actually going to graph it because it will go off the graph, but we're going to talk about the different parts and what those are going to mean transformation-wise. So let's first just identify this negative. So that's vertical, and it is going to be a reflection. And vertical reflections go over the x-axis. So this is a reflection over the x-axis, just for that negative piece. Now let's look at the 1/2. So that 1/2 is vertical. So it's a vertical, and since it's a fraction, it is a compression by 1/2. Next is going to be the 5 that's in there, that -5, and remember it's opposite thinking, and that is horizontal, so is that moving us left or right? So opposite thinking would be 5, and we're moving 5. If it's positive, we're moving to the right. And then last but certainly not least, out here is vertical movement. and that would be moving us up or down, and since it's a positive or a plus, it would be 12.5 moving us up. So that's what all those kind of parts, putting them all together from both days. So if we were to graph it, we could look at the vertex here as being 5, 12.5 in parentheses. So 5, 12.5 would be our vertex, which again goes off the graph up here, and then it would be that reflection of a quadratic or the U shape that would be upside down if we were to graph that. So here's kind of a nice summary box of how things kind of work if it's translating or sliding or moving left or right or up or down. And then the dilations, that vertical and horizontal stretches and compressions, and then the reflections. So just kind of a good summary piece. But practice really is going to make things go a lot smoother because you are going to see this in the next few chapters. So practice, practice, practice.